I'm building a mini table saw that's powered by the Dremel flex shaft. The first step was to build a cardboard mock-up. This way I was able to get a general design nailed down and then further refine that later in the process. The housing for the Dremel was 3D modeled in Fusion 360 and then 3D printed. It took several tries to get the parts precisely fitted to make sure that the Dremel wouldn't be moving around and that the cutting wheel would be stable. It is adjustable so that the entire setup can move forward, backward, up, and down, depending on the diameter of the blade and the length of the shaft, so that it can be centered on the slot in the top. An early version of the setup was fully assembled and attached to the cardboard table to further test the functionality, so any tweaks could be made before the final version was printed. The cardboard version was set up to have a cutout so that the Dremel could be raised further than the top of the tabletop so that smaller diameter bits could be used, but I ended up leaving this out in the later version since I plan to use only larger diameter bits anyway, and it's more beneficial to have the full smooth tabletop for cutting larger pieces of material. Now that the design has been confirmed functional, it's time to prepare the final base. I'm using some plywood for this and adding a weathered oak stain over the top. The thicker piece of plywood looked really bad even with the stain, so I decided to cover that with a piece of the thin plywood. This will also provide a thicker base for securely attaching the stand for the Dremel. The parts were all cut using the scroll saw. It's not the best tool for the job, something like a bandsaw or a proper table saw would be better, but this was the tool that I had to work with. I traced out the lines in pencil and then cut outside of the lines so I could sneak up on the exact size using a sanding block. The cuts are coming out somewhat cleaner since I've added an insert with a very small clearance. The sides for the storage box will be cut from the same thin plywood. I wanted to miter the corners for a nice clean look, so I angled the bed at 45 degrees. It did want to kick back the wood a lot, so I had to clamp it down as well as I could with my hands and just press it against that plate, hold it still, and get the best cut I could, and then again clean that up with the sanding block. To prepare for attaching the hinges, I traced out the exact size using the hinge as a reference. To create the main base, I'm gluing together those two pieces of wood. I've got the thicker piece of plywood and then the decorative piece to go on top. There's also a slight bow in the wood, so in this way I was able to get that a little bit more flat. The glue did cure a lot faster than I am used to, with it being on wood versus on plastic, so my positioning was a little bit off, but I was able to square that up with the sanding block after the glue had cured. The mitered pieces for the storage box get glued together. I first did a test fit, and they seemed to fit together well. However, once I was adding the glue, I realized that I had not quite enough clearance. I should have left a bit more space there. I'm not used to working with wood, so there were some mistakes made there, but in the end I was able to get it all held together well enough to function for this project. I didn't have the right type of clamps to hold this securely while it was drying, so I ended up just taping the pieces together with some masking tape. That worked fairly well, and it helped to pull out some of the bowing in a couple of the pieces and just hold everything together well enough to cure in shape. There was some slight gaps still in my mitered corners since my pieces ended up not being cut quite exactly to the right size, but I filled that with some wood filler and it looked fine for this project. The back of the box is reinforced with a third layer of wood. There's 2 layers on all of the other sides for more stability. So I need to cut out the rest of the space for those hinges from the back. I used a tungsten carbide bit on the Dremel to chew away that excess wood, and then got the size exactly right using a set of files, test fitting the hinges as I went to ensure that just the right amount of material was removed for the hinges to sit flush with the top of the box. All of the wooden parts were sealed with a water-based sealer. The hinges are designed with a washer spacing between and then a bolt running through everything. The outside pieces get screwed to the wooden box, and the centerpiece will be glued to the top of the table. The screw spacing was marked out and the holes pre-drilled before screwing the hinges in place. The top for this table was constructed using fiberglass and carbon fiber, so in order to attach these hinges, they need to be glued down. I can't screw into the top since there's not enough material to hold a screw securely. I marked where the hinges need to sit on this top and roughed up the surface to ensure that the glue will have something to grip. I started out using super glue just because I wanted to test fit this, even though I knew that that wouldn't be a secure enough bond for permanent use. Luckily, the super glue only held long enough for me to realize that the hinge had a fatal error that prevented it from allowing the top to open, So this bond broke as soon as I tried to lift the top. When I first designed the hinge, there was clearance all the way around so that the top could open. Later on, I went back and made the design look nicer and more uniform, and inadvertently created a hinge that doesn't function, so I had to go back and print the first version of the hinge, and that's what I used to attach permanently to the top using epoxy and carbon fiber. I used the faulty version of the outside hinge pieces as spacers while the centerpiece was curing on the top. Once that was partially cured, I was able to remove the hardware, lift the box, which was not screwed into the hinges at this time, and ensure that the center pieces stayed adhered to the top, while the side pieces could be removed fairly easily since the epoxy was only partially cured and there was only a small amount of seepage underneath. The epoxy was then allowed to cure completely to form a secure bond with the top and the centerpiece of the hinge. To attach the box to the base, I printed out some simple brackets. A template is used to position them uniformly on each side of the box, and then holes are pre-drilled in both the top and the base, and everything is screwed in place. The final version of the flex shaft housing was printed using Proto-Pasta matte fiber HD PLA. This provides a nice aesthetic finish. It's also easy to clean up and very rigid. In the early stages, I noticed that the trolley wanted to fall out of the lower housing, so I've added in some stops to the front that can twist to allow the housing to be removed from the base, and then closed to ensure that the Dremel is secure while it's in operation. Spaces were designed for washers and screws to be added. The washers were glued in place, and ultimately the screws will be glued in place also. The holes in the model were slightly smaller than the screws that were used. Now you could just screw directly into the plastic and that holds fairly well, but in this case I decided to drill out the holes somewhat so that the screws would be loose inside the hole, and then the holding power would be from the nut only. The nuts are attached to knobs so that they can be easily turned without the use of a tool. The original idea was to cement the nuts in place using melted plastic and a soldering iron. However, I figured out later on that this didn't have any real function. It worked just as well just to glue the nuts in place. I ultimately revised the knob design so that the nut would sit flush with the top instead of being sunk into the plastic. Most of the parts are held together just with screws. However, the lower tab piece that attaches to the main housing for the Dremel needs to be glued and then plastic welded in place to ensure a secure connection. This allowed for easy printing, and it's just a small amount of post-processing to bond everything together permanently. To keep the Dremel housing straight when it's being adjusted, a connection was added between the center points of the legs. This was created using a piece of carbon fiber tube and some 3D printed connectors. The parts were super glued into the tube so that the screw would be held stable while the nut was screwed on from the outside. Before getting too far in the assembly process, I'm going to go ahead and attach the Dremel trolley to the base. So I marked out where this needed to sit to be right in the center of the platform. I pre-drilled the holes and attached the parts together using wood screws. It would be possible to do this after the trolley has been fully assembled, however it's a bit easier to do it right now. Now that everything's attached to the base, it's time to add the final connection points. Most of the screws were pre-glued into the leg pieces, however the bottom parts need the screws left loose so that it can be fitted together and then glued into place after all of the pieces have been attached. A washer was added between each of the knobs and the leg pieces for smoother adjustments. Degree markings were printed into each of the leg pieces to make it easier to adjust the legs to the same angle. The top can now be fitted to the base and the hinges screwed in place. This tabletop was constructed using carbon fiber and fiberglass, but it could also be created using another piece of the plywood. In the original cardboard version, there were brackets to keep the tabletop from opening too far. In this case, each hinge has a built-in stop so that the top will sit at slightly wider than 90 degrees for easy access to the storage compartment. Some of the key elements that I wanted for this design were to be able to remove the Dremel easily so that I could go back and forth between using the table saw and using the hand tool. Also, I wanted to be able to change the bits without having to remove the Dremel from the trolley, so that determined the spacing from the front to the box. With everything assembled, the trolley can be adjusted so that it aligns with the hole in the top. All of the joints can be hand tightened due to the knobs on the nuts, so it's nice to not have to pull out any tools to get this tightened up. The cutting wheel is set to the desired height, which is limited by the height of the Dremel flex shaft itself. Now, in the original version, I had the cutout so the Dremel could be raised higher. In this case, I decided to just keep my top flat for now, and then if I decide later that I want to have the cutout, I can go ahead and modify it for that version. In this case, it just needs to be a 40mm sanding disc so that it reaches high enough past the tabletop for cutting thin materials. The original design included the front supports. However, since I decided to keep the tabletop as one solid piece, not do the split top, I've left those out for now. I think the composite top may be rigid enough to work without them, but they'll be added later on if there ends up being too much flex in the top. It doesn't work great for cutting wood. However, I think these bits are not great. They were just the cheapest set I could find on Amazon so I could test out what sizes would work. Later on, I plan to buy some better quality bits to make this tool as functional as possible. But even with these low quality cutting wheels, it works really well for cutting through thin composites. The storage compartment is sized so that the Dremel can be stored inside when it's not in use, along with any bits. The table setup still needs a cutting guide and possibly some safety features so that other types of bits could be used, so those upgrades will be added in future.